Good evening, everyone. Now, this is the next lecture of properties, in which I am explaining the properties of moduli of complex number. One property I have left in the conjugate of complex number P9. It is Z1 and Z2, conjugate of Z1 and Z2 conjugate whole. It is equal to Z1 conjugate upon Z2 conjugate. So this you will just learn. P1. It is again P1, properties of modulus. So as we have discussed, Z bar is conjugate, it is equal to mod of Z square. This we have already proved, this property. Now, next property is property 2 of moduli. Z1, Z2 moduli is equal to modulus of Z1 into modulus of Z2. If we will prove, we will get it. So if you want to see, otherwise I am coming to, because it is easy one, so I am coming to the next property 3. Modulus of Z1 upon Z2, it is equal to modulus of Z1 upon modulus of Z2. Now next property 4 of modulus. Here we will prove modulus of Z1 plus Z2 is less than equal to modulus of Z1 plus modulus of Z2. So this is important one. So here this property will be proved. So here I am taking we know that proof, we know that mod of Z square, it is Z bar. This we have proved earlier. This is the property of modulus as well as in conjugate. So any complex number is multiplied with conjugate, it is equal to modulus of the Z, modulus of Z square. So if we will take modulus of Z1 and Z2 square, and we will treat Z is equal to Z1 plus Z2. Let us suppose here the whole thing, the sum of the two complex number is also a complex number. So Z1 plus Z2 is treating as Z. Then we can use Z1, Z2 in place of Z I am writing, and now Z1 plus Z2 conjugate, whole conjugate. With the help of this property, I have written this, and I have assumed Z1 plus Z2 is equal to Z. Is it clear? I think it's clear, as you know that the Z1 and Z2 conjugate is equal to conjugate of Z1 plus conjugate of Z2. This you have learned. So Z1 plus Z2, and here I am writing Z1 bar plus Z2 bar. So up to this there will be no problem at all. Now we will just multiply. Z1 Z1 bar, this is multiplied with this. Now Z1 Z2 bar. Now this Z2 Z1 bar, and here is Z2 Z2 bar. This is the for the explanation. This is the part of the explanation. So now see, Z and Z1 bar can be written as modulus of Z1 square, and now Z1 and Z2 bar is written as it is, and Z2 and Z1 bar written as it is, and this we can use again this property here. This is written as Z2 modulus of Z2 square. Now I am writing these two together. Z1 modulus square plus modulus of Z2 square plus Z1 Z2 bar plus Z2 Z1 bar. Now this, up to this we have done. Now we will see this is taken as 1. Now here we are taking only these two terms. So Z1 Z2 bar plus Z2 Z1 bar. Z1 is taken as x1 plus iy1, and Z2 is taken as x2 minus iy2, because Z2 bar is taken as this. Z2 is what? X2 plus iy2, and here Z2 is written as x2 plus iy2, and Z1 is written as x1 minus iy1. So if we will multiply here, so x1 x2, this is multiplied I x1 y2, then I y1 x2, and here will be minus I iota square y1 y2, then we will multiply this. Here is plus x1 x2, x2 x1, now I x2 y1, then iota y2 x1, see, and then this will multiply with this, so minus iota square y2 y1. In place of iota square we will put minus 1. So just see over here, minus x1 y2 minus plus x1 y2, so this and this will cancel, and this will cancel, and where I square, in place of iota square we will put minus 1, so x1 x2, and then again x1 x2, so it is 2 x1 x2, and this is plus y1 y2, and it is y2 y1. So see, twice x1 x2, twice y1 y2. So if we will see here, we are getting this 2 will be taken common, x1 x2 plus y1 y2, y1 y2. So as we know that if we will multiply z1 and z2, we will get the real part of this. Real part of z1 z2 is equal to twice of this x1, x2 and y1, y2. This we will get. So in place of this we can write twice real part z1, z2, z1, z2, z2 bar. Here will be bar. If we will take z1 and z2 bar and we will multiply together, the real part will come this. So here we can write it. So in place of this mod of from this is taken as 2. So in place of this we can write 2 twice of real part of z1, z2. So see, here will be z1 from equation 1 and 2, z1, z2 mod square is equal to mod of z1 square, then z2 square, then plus twice real part z1 and z2 bar. So this is positive, this is positive, so we can write this, that this is equal to, this is square over here, and here we have to prove that the modulus of this, here just see, here we have to prove the modulus of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. So from here we will write, because of here we have written this real part of this. So again we are writing here as it is less than or equal to z1 square, and it is z2 square and plus twice modulus of z1 and modulus of z2, since x is less than or equal to root under x square plus y square. Suppose z is a complex number x plus iy, then real part of z is equal to x and modulus of z is equal to root under x square plus y square. So x is always less than or equal to square root of x square and y square, because x square is positive and y square is positive. So it is equal to this, because when y is equal to 0, then it is x is equal to x, and when y is either negative or positive, so square root of x square plus y square is always greater than x. So in this case the real part is always less than or equal to square root of, means modulus of the complex number. So therefore I have written here less than or equal to sign, and mod of z1 square plus mod of z2 square plus 2 mod of z1 and z2. Therefore we can write z1 plus z2 square is less than or equal to mod of z1 plus mod of z2 whole square, because it is in the form of a square plus b square plus 2ab. Now we will removing the square root sign. So taking only removing the square root sign, we will get, therefore modulus of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. This is also known as triangle inequality, and this can be proved with the help of polar form also, so that I will discuss in the next video. So is called triangle inequality. Triangle inequality. Triangle inequality means in geometry, the sum of the two sides of a triangle is always greater than the third side, or any one side of a triangle is less than the sum of the two sides of a triangle. So with the help of the geometrical proof, or with the help of the polar form, we can prove it. So thank you. So please like, share and subscribe. This is the algebra of complex number, a little bit boring, and now we are coming in the question. Then you will also enjoy. So please go through it once again so that you will understand this topic, because this type of question will be asked in the examination. Thank you. Bye bye. Have a nice day.